Namaste. I, Nitika Chatwal, Assistant Professor in Jyoti Vidyapeeth Women's University, Jaipur, Faculty of Pharmaceutical Sciences, is here to deliver the lecture on micromeritics, which is in Physical Pharmacy second, and that is the unit 4 in which micromeritics comes under. Now let's start. Density of powders. Density is defined as weight per unit volume. During tapping, particles gradually pack more efficiently. The powder volume decreases and the tap density increases. Right? In this, the density is volume divided by weight. Weight divided by volume is equals to density. Right? In this, we calculate density of powder, which is very important for micromeritics, right? Now, type of density, these are of two types, true density and bulk density. In true density, the true density or absolute density of a sample excludes the volume of the pores and voids within the powder sample. Bulk density. The bulk density value includes the volume of all the pores within the powder sample. Right? Now, flow properties. Flow properties also affect micromeritics or other manufacturing techniques, because in manufacturing of capsules, tablets, these are very important factors. If we control flow properties of powder, then we can make a very absolute tablets and capsules which are of high quality and high bioavailability. Powders may be free flowing or cohesive. Cohesive means what? Sticky. They are come closer to each other. Many common manufacturing problems are attributes to powder flow. Powder transferred through large equipment such as hopper. If powder is uneven or it have uneven flow, then excess entrapped air within the powder is seen, and this causes capping or lamination, which is a, a tablet disabilities. Capping or lamination is very main common problem in tablet manufacturing. By this capping or lamination, the tablet is deformed or not in acceptable limits. Uneven powder flow increases particles friction with dye wall, causing lubrication problems and increase dust contamination risk during powder transfer. Then this will cause low quality tablet manufacturing, and after manufacturing low quality tablets, they can't be go through quality assurance process, and they will be deleted or uh, rejected from the tablet machine, right? So that's why flow properties are very important in manufacturing of tablets and capsules, right? So this will be an important question for any examination, like write flow properties of powders, are what are the flow properties of powder, uh, how they differ from other properties, or how it will going to mm, enhance the manufacturing, right? So this is the main topic. Now, flow properties of powder helps in powder storage, which, for example, result in caking tendencies within a vial or bag after shipping or storage time. Separation of small quantity of the powder from the bulk, specifically just before the creation of individual doses, such as during tableting, encapsulating, and vial filling, which affects the weight uniformity of the dose under or over dosage, right? Now, what are the flow properties of powder? There are many tests to evaluate the flowability of a powder, And these tests are, first one is Carr's compressibility index, which is also known as sometimes Carr's index. Second one is Hausner's ratio. And the third one is angle of repose. The angle of repose also denoted by the term theta. Theta. Okay. Now we will discuss this as one by one. Now first one is Carr's compressibility index, which is also known as what? Carr's index. A volume of powder is filled into a graduated glass cylinder. What is graduated? In which marks are present, like 50 ml, 40 ml, and they are gradually marking present over it, like, right? So that is called as what? Graduated. A volume of powder is filled into a graduated glass cylinder and repeatedly tapped. Tap means we tap it for several number of times for a known duration. The volume of powder after tapping is measured, right? Carr's index is equals to what? It is comes in percentage, and the formula of Carr's index is tap density minus pore or bulk density divided by what? Tap density into 100. By this formula we can calculate what Carr's index will be for a powder or for a sample, right? Now Carr's index Car's compressibility index has a table in which there will be flow descriptions and percent compressibility. So there will be a relationship between powder flowability and percent compressibility. If percent compressibility is 5 to 15%, then the powder flow will be excellent. And if percent compressibility in between 16 to 18, then the powder flow will be good. And if the percent compressibility is in between 19 to 21, then the powder flow will be fair. And if the percent compressibility is in between 22 to 35, then the powder flow will be poor. And if percent compressibility is in between 36 to 40, then the powder flow will be very poor. And if the percent compressibility is higher than 40, then it will be extremely poor. So we cannot take percent compressibility as higher than 40. If a powder or a substance has Carr's index higher than 40, then we don't take that substance, or we do anything else. We do flowability enhancer agents. We add flowability enhancer agents in it to enhance what? Flowability, like glidant. For example, glidants are the main which enhances powder flowability, right? Now what is Hausner's ratio? Now Hausner's ratio is equals to tap density upon pore or bulk density. Hausner's ratio was related to interparticle friction, right? Value less than 1.25 indicates good flow. It also has a table like Carr's compressibility index. If the value is less than 1.25, that will indicate what? Good flow, equals to 20% Carr's index, right? If the powder with low interparticle friction, such as coarse spheres, then the value will be greater than 1.5. That indicates poor flow, right? Now, more cohesive or less free-flowing powders such as flakes have between 1.25 and 1.5 Hausner's ratio, in which glidants are added normally to improve flow properties of a powder. If there is a Hausner's ratio is higher than 1.5, then adding a glidant doesn't improve any flow properties of a particle, right? So there should be no higher than 1.5 Hausner's ratio. If there will be 1.5 higher than 1.5 Hausner's ratio, this will never improve any flow properties of a particle. So adding glidant will not improve any flow properties, right? Now the last one is the angle of repose, which is represented or denoted by what? Theta. Now The sample is poured onto the horizontal surface and the angle of the resulting pyramid is measured. What is measured in it? A resulting pyramid, right? Pyramid is of what? A triangle shaped pyramid, right? Now that is measured to know what is the angle of repose of a powder is. The user normally selects the funnel orifice through which the powder flows. What he takes? A funnel. He take a funnel and add a powder by which it flows and make a what? Pyramid. Flow slowly and reasonably constantly. In it, flow maintains a constant variation, right? Now the angle of repose, which is theta, has also a table in which if the angle of repose is less than 20, then the flow will be excellent. And if the angle of repose in between 20 to 30, that will be a good flow. And if angle of repose in between 30 to 40, the flow will be passable, right? If angle of repose is in between or greater than 40, then the flow will be poor. Now, this is very important for GPAT aspect because they will come in MCQ questions like what is the angle of repose of this powder. If the powder has angle of repose 20, then flow will be what? Excellent, good, passable or poor, right? So this is important for any examination and mainly it is important for GPAT exam, right? The rougher and more irregular the surface of the particles, the higher will be the angle of repose, right? If the surface is rougher and more irregular, then the angle of repose will be higher, right? And if the angle of repose will be higher, then what happens? Flow will be poor, right? Now, what are the factors that affect flow properties of a powder? That is directly proportional to improvement of powder flowability, right? If we control these factors, then the powder flowability will also enhance or improve, right? If we What are these factors? First one is particle size and distribution. If we say about particle size and distribution, then we know if particle size is small, right, then powder flow will be improved. Like this, these factors affect very much about the flow properties of a powder. Second factor is particle shape and texture. This also improves or degrades the flow properties of a powder according to its shape and texture. Now, surface forces is another example of factors, and last one is flow activators, which also affects the flow properties of a powder. Now, um, by altering particle size and distribution, we can affect the properties of flow properties of a powder. By altering particle shape and texture, we also affect the flow properties of a powder. By altering the surface forces, we also affect the flow properties of a powder. And last one is what? By adding additives or formulation additive, which also called as flow activators, we will affect the flow properties of a powder, right? Now, first one we came in detail by one. Now, first one we take alteration of particle size and distribution, right? There is a certain particle size at which powder's flow ability is optimum, right? Everything has its optimum value. Of course, particles are more preferred than fine ones as they are less cohesive. The size distribution can also be altered to improve flowability by removing a proportion of the fine particle fraction or by increasing the proportion of coarser particles such as occurs in granulation, right? Now, what alteration of particle shape and texture, in which we alter particle shape of a powder, then it will or no, obviously affect the flow properties of a powder. And how it will affect? Generally, more spherical particles have better flow. property, then more irregular particle. If the particle has irregular size or shape, then it has low or slow flow properties. Spherical particles are obtained by spray drying. Spherical particles are obtained by what? By spray drying. That is a technique which is included in the tablet drying process or any other substance drying process, in which dryers are used, like coated spray coated dryers and other dryers, or by temperature cycling crystallization. This is the another technique. Now, alteration of particle shape and texture, in which particle texture can also affect the flow properties of a powder. And how it will affect? Particles with very rough surfaces will be more cohesive and have a greater tendency to interlock than smooth surface particles, right? Now, by altering surface forces, we can affect the flow properties of a powder. Reduction of electrostatic charges can also improve powder flowability. How electrostatic charges can be reduced? By altering process condition to reduce frictional contacts. Moisture content of particles greatly affect powder flowability. Absorbed surface moisture films tend to increase bulk density and reduce porosity. Drying the particle will reduce the cohesiveness, right? Cohesiveness is what? In previously we studied, right? The cohesiveness is sticking. The particles agglomeration is what? Cohesiveness. The drying process will reduce the cohesiveness and improve the flow. Hygroscopic powders stored and processed under low humidity condition. What are the hygroscopic powders? Which absorb moisture from the environment. These are the what? Hygroscopic powders, right? Now, formulation additives, how flow activators affect the flow properties of a powder. Flow activators are commonly referred as what? Glidants, which I termed previously, right? Glidants. Flow activator improve the flowability of powder by reducing adhesion and cohesion. For example, talc, maize starch, and magnesium stearate. These are what? Flow promoters or glidants. Now, this will also an important question for GPAT or other examination for pharmacists, right? What are the glidants, or give examples of glidants, right? Okay. Now, what are the derived properties of powder? Solid state characterization have many derived properties, and what are these? First one is porosity, second one is polymorphism, third one is molecular structure, fourth one is crystallization, fifth one is shape, sixth one is density, seventh one is size, eighth one is surface area, right? These are all the properties which are derived properties of powders. So thank you. That's it for this lecture. If you have any queries, please comment below. And now what you can do, you can make your own lecture notes by preparing by yourself to study, right? Thank you. If any queries, please comment below. Thank you. Thank you so much. Thank you for your cooperation.